Okay, here's warm-up number 26. So I'm going to simplify this by doing some division. You could do long division, but I'm going to do synthetic division. This qualifies because it's x plus or minus something that I'm dividing by. Okay, now looking at this part, I'm looking for any missing terms and go from x to the fourth to x to the first. So it's missing x to the third and x to the second. So I'm going to imagine that it has these two terms in that slot between x to the fourth and x to 5x. Okay, so when I set up my synthetic division, I'm going to take the opposite of the 2. Think of x plus 2 equals 0. X would equal negative 2 then. Okay, so that goes in that box. 4 is my leading coefficient, but then I've got the two zeros. And then 5, and then negative 4. There's all the coefficients. Okay, then I'll skip a line, draw a little box like that. Okay, so I'm going to pull this first number down. Then I'm going to do negative 2 times 4 would be negative 8. Now I add 0 plus negative 8. And then every time I get a number on the bottom here, I multiply it back by negative 2. Negative 8 times negative 2 is 16. Every time I get 2 above the bar, I add them together. 16 times negative 2 would be negative 32. Add these two together, that gives me negative 27. And then negative 27 times negative 2 would be 54. Add those to get 50. Okay? And then I'm going to build this back into a polynomial. So 50 is going to be the numerator of my remainder. Whatever I'm dividing by is the denominator. Okay? And I always want to add in my my remainder fraction. Okay? This is just a negative 27, and as I go to the left, each one of these, I'll add 1 degree of x. So this is negative 27, this would be 16x. This is going to be negative 8x squared. I'll separate those with a plus. And then this would be 4x to the third. And I did it way quicker than long division. Okay? You can also use what's called synthetic substitution for a problem like number 2, which is what I'm going to do. Now you could also just plug in all the x positions and multiply it out and use PEMDAS, and that's fine. It's not really that difficult to do it that way. But just since we just learned synthetic division, let's go ahead and try synthetic substitution as well. Now this is also missing a term here, so I'm going to have to keep that in mind since I'm going to do this synthetically. Okay. Now a big difference here is I often see people put negative 2 there, and I get why people do that because you're kind of switching the signs when we're doing synthetic division. But for synthetic substitution, we're not doing that. Because if you think what the x value would be here, if you set this equal to 0, it'd be negative 2, right? But here the x value is 2, so I'm just putting that number as it is. Okay. Now I'm going to write out the coefficients, and I'm not going to forget the 0 in there. I didn't need the plus, sorry. The 0, 5, 2, 0, negative 20, and negative 6. Okay. Now I'm going to do the synthetic division just the same way I did before, but I really only need what goes in this slot. This is going to be my solution. Okay. So let's pull down the 5. And 5 times 2 is going to be 10. Add these, 12. 12 times 2 is 24. 0 plus 24 is 24. And 24 times 2 is 48. Negative 20 plus 48 is 28. Double that for 56. And then negative 6 plus 56 would be 50. So this number is what f of 2 is. That's what you should get if you plug in 2 for x into that equation and do it the old-fashioned way, which is fine too. Okay. All right, and then we've got a bunch of factoring on the right side. So factoring, we're breaking this apart into factors, into a multiplication problem. So first thing on all of these, I'm looking for a common factor, and here 2 goes into all 3 terms. So let's factor that out. Kind of just thinking dividing all pieces by 2, but then I've got the 2 out there still. Okay. Now this is partially factored, but we can factor it further because I've got a trinomial that I should be able to factor like so. I'm going to use a diamond problem using negative 1 on top and negative 6 on bottom, and I want 2 numbers that'll add to negative 1. Same 2 numbers multiply to negative 6. Okay. So let's see. You can write out all the pairs. I'm thinking of ways to multiply to get negative 6. So a 1 and a 6 is not going to do me any good, but I can do something with a 2 and a 3. If the 2 is positive and the 3 is negative, that's my winning combo, right? So that tells me what goes in the back of these. Okay, and this is completely factored. Okay, now on the next problem, I can't just factor out a 2 because it's not a common factor. There are no common factors here, but I can still factor this. I'm going to do this with a modified diamond problem. So that means I'm going to take this 2, since I can't factor it out, I'm going to multiply it by the -3. So it's just going to disappear from the front. 2 times -3 is -6. Okay, now I'll factor this piece with a diamond problem. Okay, so a 1 and a 6. Oh, I can do something with a 1 and a 6 if the 1's positive and the 6 is negative, right? So this is going to factor into x plus 1 times x minus 6. That's not my final answer, though, because if I multiply that together, I don't get my original trinomial here, okay? So I got to change this answer. So then what I'm going to do is, in the beginning, I multiplied by 2. Now I'm going to divide the number parts by 2. Just the constants I'm dividing by 2, okay? And I'll simplify those as much as I can. I can't simplify 1/2, so then I'm going to pull the 2 out in front of the x, and the 1 will fall to the ground. So that first binomial is going to be 2x plus 1, and then 6 divided by 2 is just 3. So I've got x minus 3, and this now is completely factored. You can always test it out, multiply it back together, should give you that. Okay. Next up, I do have a common factor here. 3 goes into everything, right? So let's factor a 3 out. So I'm thinking 3 times what is 6x squared, 3 times what is 9x, that would be 3x, and 3 times what is -6, okay? And now this remaining part, I'm going to factor again, okay? Now, you can do this with a modified diamond problem. I'm just going to show you how you can do this without a modified diamond problem, kind of by just doing some of this work in your head. So, honestly, with a simpler trinomial, I wouldn't actually do a diamond problem on one like this. I just think, okay, I'm thinking FOIL. I know those are the first. They have to multiply to get 2x squared, okay? And then the lasts are going to multiply to get -2. So there's not really that many ways, right? You have your different options are -1 and 2, 1 and -2. Or, since I have different things in the front, I could reverse the order of those. So 2, -1, or -2, +1. So there's really 4 different options for these slots, but it's going to be 1s and 2s. So then I kind of just play with the options. So this is how I usually kind of think about it. I might write them in like that. I haven't put the signs in yet, but I'm thinking the outer and the inner, I've got to be able to get a 3 with that. So I'd have 4x and 1x. Well, I can get a 3x with a 4x and a 1x if the 4x is positive and the 1x is negative, okay? And that's bugging me. Just missed there, kind of. Okay, and that's my winning combo, but you could do the same thing we did up here with a modified diamond problem as well. Okay, or there are other methods as well. All right, last 2 problems. I've only got 2 terms, so I'm still looking for a common factor. I don't have one here, but hey, this is a difference of squares. It's a difference because I got to, subtraction, right? And then this is a perfect square because x times x equals x squared, and 5 times 5 equals 25. So the pattern here, this is going to factor into x plus 5 times x minus 5. Okay? You could also put a 0x in the middle and do a diamond problem. That'll get you the same result. But it's good to know that pattern with a difference of squares. All right? Looking at these 2 terms, these aren't perfect squares. Nothing times itself equals 2. Or 2x squared, nothing times itself equals 98. But I've got a common factor here. Since they're both even, let's factor that out first. And now the remaining binomial in there is a difference of squares, right? Because 7 times 7 is 49. So I've got 2, and then it's going to be x plus 7 times x minus 7. And that's the end of the warm-up, and I'll see you next time.